So at the University of Waterloo Alternative Fuels team participating in the EcoCAR Challenge. Challenge is a key operative word. We've had a lot of engineering challenges taking this vehicle from a completely stripped down metal chassis to a fully integrated powertrain. Some of the biggest challenges have been, first and foremost, packaging and integration. We're putting very large components in this car that were never designed to fit. There's a lot of mechanical design and analysis that goes into figuring out where things are going to go, where are we going to run cables. How can we possibly get these 2 or 3 things to fit in such a small space at the same time? And as you can see, losing our rear seats was one of the consequences of choosing a hydrogen powertrain and having the hydrogen tanks that go along with it. That's been a major mechanical challenge in our team, and our team members have really risen to that challenge and produced what we think is a really great mechanical integration given the complexity and the volume of the components. Another major engineering challenge that's common to a lot of the teams in the EcoCAR competition is battery pack design. A lot of teams are using A123 systems donated modules to build a high voltage battery pack that provides propulsion power for the team's electric motors. In our case, we rely on the battery pack very heavily for propulsion in our vehicle. And the great thing about battery packs in this competition is that we get to design them ourselves. We receive cells built into modules from A123, and we do all the mechanical design, the integration, the placement, high voltage electrical, low voltage electrical. And it's been an amazing design experience to have so many different engineers with different backgrounds and different specialties work together to build this really great integrated package that we can put in our car and make it drive. Finally, the integration of a high voltage battery and a high voltage fuel cell system onto the same motor bus presents a big challenge for engineers. 2 systems operating at 2 different voltages trying to power the same motors generally doesn't work out very well, which means we have to have what we like to call a magic box. It's a DC to DC power converter. It basically takes energy at 1 voltage and turns it into energy at another voltage so that our 2 energy sources, our battery and our fuel cell, are compatible with each other. The team in EcoCAR decided to take on the challenge of building a bidirectional buck-boost DC to DC converter for ourselves. We had some great engineers put some great work into creating not only the electrical architecture for the converter, but to do all the mechanical design and integration to actually get it built into our battery pack and built into our vehicle. Unfortunately, coming up to 2 months left in the EcoCAR competition, we weren't able to get our DC to DC converter to the quality and testing level that we required to get it into our car, which meant that we were very fortunate to receive a donation to purchase this Brusa DC to DC power converter. This tiny little box is essential to hybrid operation for our car, and we're hoping in the coming weeks to have it fully integrated and tested so that we can run as a fuel cell hybrid.